Example 4.8. In the figure, the straight line L1 passes through the point P and cuts the y-axis at point A. B is a point on the x-axis such that PB is parallel to the y-axis. Part A, find the value of k. So we look at L1, which passes through the point P. So we'll make use of point P as well as the equation of L1 to find k. K equals -8. So let's see what's L1 when k equals -8. Equation of L1 is y equals 2/3x minus 8. And the y-intercept of L1 is -8. And since L1 cuts the y-axis at point A, we can make use of the y-intercept to get the coordinates of point A. Part B. If Q is a point on the y-axis such that the area of triangle APQ is equal to the area of the quadrilateral OQPB, find in part 1 the coordinates of Q. Note that OQPB is a trapezium. The upper base of the trapezium is OQ. The lower base is BP, which is 4 units, and the height of the trapezium is 6. You can refer to the diagram. For triangle APQ, which I have highlighted green in color, its base is QA and the height is 6. Since Q is a point on the y-axis, I'm going to let the coordinates of Q be 0Q. The area of triangle APQ equals the area of OQPB. So we have 1/2 times QA times 6 equals 1/2 times OQ plus 4 times 6. After simplification, we have QA equals OQ plus 4. And let's express QA in terms of lowercase letter q. Referring to the diagram, the length of QA is Q minus -8. You always take the greater value, which is Q, minus the smaller value, -8. So that will give us the length of QA. OQ, on the other hand, will be 0 minus Q, because you are taking the origin 0, 0, and the point Q, 0Q. So you take the greater value, 0, minus the smaller value, which is Q. So OQ is 0 minus Q. We get Q equals -2, and therefore the coordinates of point Q are 0, -2. Lastly, part B, part 2, find the equation of PQ. So we are using point P, 6, -4, as well as point Q, 0, -2. So finally, we get the equation of PQ, y equals -1/3x minus 2.